Hello again, ACST1052 students. This is Doug Fletcher with the last in the series of videos on dynamic arrays in Excel, working through a couple more advanced techniques, this time in constructing a life table. So our little conceit here, if you like, is that we're going to do this using formulae only in the top row of the life table and control the whole life table from there. As usual, in a fairly large table like this, we want to be able to see both ends of it. So I'll split the screen, going to the View tab and the split icon over here. Now I've actually got the selection in the wrong place, so I want to split about halfway down the screen like that, and we'll go back and try that again. Okay, so there we are. And I'll just go down the list of these. This is a QX list of values over here, and just so we can see both ends of the table. Now, I've stored my QX values off to the side here, partly because one of the things you can do quite easily is store a whole lot of QX values for different life tables you might want to use, and then use a lookup to drag them across. That might be a subject for another day. But what I'm wanting to do here is just pull those QX values in using a single formula, and that's just simply a range reference. So from over here, I want to put in a formula, and I'm going to refer to this whole range, and that goes in there as a single reference with it just lists all the values like that. Now, for these this life table, it happens to be an Australian life table, 2015 to 17, and we know that it starts from age 0. So one of the first things we're going to do is define the age vector, and we want this to respond to the mortality rates that are pulled in. We're assuming that we start from 0, so we'll have a sequence here that starts from 0. That'll be a bit later on, but we want to actually have the number of rows taken from the QX vector. So I'm going to count the number of rows in that whole list, and I'm going right down there. We're going to have a single column. We're going to start from 0, and we'll use the default step of 1. And so there we go, we've got our ages. And that's, if we had more QX values or less QX values, as soon as we pulled them into the table, this the age, the X column would respond to that and just have an age corresponding to every QX value, assuming, as I say, that we're starting at age 0, which for the Australian life tables we do. Okay, the next thing that's handy, and the fairly obvious thing to do, is to calculate the PX values. And this is, of course, extremely easy. So easy, in fact, that even I can make a mistake. So we need to start a formula with an equal sign, and we simply want 1 minus the QX values. The next thing we can do is LX, and this is where it starts to get a little bit tricky. Now, how is LX calculated? Well, we start with 100,000. And what we're going to do is we then multiply through by the PX column. And we're actually taking successive products through here. So if from our 100,000, we want to multiply by P0, and that'll give us L1. Then we multiply that result by P1, that'll give us L2. Then we multiply that result by P2, and that'll give us L3, and so on. So this is a job for the scan function, which I introduced in the previous video. So let's see what we get if we try and work this through. We're going to have the scan. We're going to start from 100,000. It's the usual value. The array we're going to scan is going to be the PX column. And we're doing products. So we need our lambda function, the anonymous function that goes in here, to be one that calculates products. So we have our initial value, the A that then serves to accumulate the successive products, and we have the value from the array. And then the function is actually going to be the product of those two things. So that'll scan through, starting at 100,000, multiplying by successive PX values, and let's see what we get. Oh, it didn't like that. I've done something wrong. Oh, I can't spell lambda, okay? It's LAMBDA. Let's see if that works. Okay. Now, that's okay, except that we actually want to start at 100,000 and have this whole list of LX values pushed down by 1. So we'd really like to tag 100,000 on the front of that. And the way in which you can glue things together is using the VSTACK, V for vertical. So we're going to vertically stack 100,000 and then the results of what we had before. And that'll give us an array that does give us what we want. Okay, now just note that we actually have one more LX than we have X values. And that makes sense because the L0 value is an arbitrary large number. And then we've got 109 PX values, which will give us the subsequent LX value. So it actually goes up to 110. We might want to add a row to our sequence for the X column. That'll just take that down to 110. Looks a little better. And we'll find one or two other little things where we need to make an adjustment. Okay, now we could do the DX column. So what we're going to have here is we want LX times QX to give us this. But initially, if we do that, we are going to run into a little problem here. So we do the LX value, times QX, and this should basically work, but, and it does, which is nice, but you notice that we have this not available value down here because there's no QX value for 110. So just to tidy this up, we need to take the LX column but drop the value off the end of it. And we do actually have a drop function that lets us do that. So we're going to drop things off the LX column. It starts at B5. Now, if we said drop 1, that would drop the first element. But if you want to drop the last element, you need to use -1. Or if you wanted to drop the last 3, elements in the array, you could use -3. So the convention is negative drop numbers start from the end of the array and positive drop numbers start from the start. We're just dropping the last one, so we have a -1 here, and that'll leave everything in place, but it'll get rid of that NA error at the bottom there. So that's looking pretty good for everything except for the expectation of life. Now, here we come across a little problem, and that is that it would have been tempting to use a recursion formula for this. So this is something that you may be familiar with, and I'm just moving things aside so I can actually write on the screen here. So there's a recursion formula that we could have used and may have been attractive, and I'm just going to put it up here and then I'll explain why we're not going to use it. And it's a source of some annoyance to me, I must admit. Now, the thing about recursion formulae is you'd look at that and you think, well, that's what the Excel scan function does. It's basically a recursion formula. And I need to emphasize that I have tried this, and it actually, the scan function actually creates errors. I'm disappointed to say that, but it is true. So what we're going to do is we're going to use an approach based on summing the LX column. So an alternative for E0X is to say that this is equal to the sum of all the LX values from LX and up, divided by LX, and then from that we subtract a half. Right, so that's the formula that I'm going to use here. Now, we actually run into a little bit of a need for logical analysis here in order to do this. Where we have a sum like this, and we need to have sums available from every age value, it's tempting just to use the scan function. And when you do that, unfortunately, what you would get at age 0, you would have L0. At age 1, you would have L0 plus L1. At age 2, you would have L0 plus L1 plus L2, and so on. It works its way from the start of the table to the end, and we do not have a way to tell it to start at the end of the table. All right, and to get this this sum to work, we need to start from the other end of the table. So the very last entry in our sum is going to have only L110. Then at 109, we're going to have L109 plus L110 and so on. So if we work backwards from the end of the table, then our scan function is going to work. So what we're going to need to do is to sort the LX column. Now, it's very handy from this point of view that the LX column is monotonic decreasing, because people don't enter other than at the start where we have our arbitrary radix of 100,000. So what we're going to do is we'll have a scan. Because it's a sum, we're going to start, our initial value will be 0. The array we're going to use will be the sorted LX values. And because we're sorting from smallest to largest, so this is going to reverse the age order. And the function we're going to scan through with is a lambda function, which I will try and spell correctly this time, which has an accumulator and a value from the array, and we're doing we're doing an addition this time. So it's a cumulative sum. So what this will do is that this will sort LX values, this will sum LX values starting from the last one and coming back to the lowest one. All right, now I'll just expand this column so we can see the values a bit better. And what this is doing is it's starting at the last LX value. All right, so 20. Then the previous one is going to be the 20 plus the 40, which we see as 60.47. The third one, 139.33, will be the sum of the last three, and so on. So this is giving us what we want for the sum, and it remains for us to put that back into the order that we want. Okay, so, and then we'll have to divide by LX and subtract half. So now we're going to sort, but we've got a couple of other things to use here. So the array we're sorting is those results we've just obtained. A sort index, you can do that if you have a multi-column array, but we don't. The sort order, that's the important one. So the default is 1 for ascending order. We now want this in descending order, with the biggest values first. Okay, so that's what we're going to have, -1 to give us this in descending order. And then that works like so. Now, we still need to divide by LX. And we need to subtract a half. And there's our expectation of life, complete expectation of life column. Now, we need to allow for the fact that the expectation of life published with the Australian life tables is actually calculated using QX values and LX values beyond the published ages. It actually uses ages up to about 120, and so we can't exactly reproduce their values. But from around about age 90 downwards, there's practically no difference. Okay, so these work to reproduce the Australian life table official expectation of life up to around about age 90, and from that point it diverges first very slowly and then a bit more, simply because we don't have those results for the very, very advanced ages beyond 110. Okay, so that's how you can do a life table, which will always adjust to suit whatever bunch of QX values you pull in. And this is just makes the assumption that the ages start from 0.